All right, this is section 1.5 from yesterday. We're going to talk about vertical asymptotes today. You guys have heard vertical asymptotes. I know in Algebra 2 you talked about it last year in pre-calc, and we're going to talk about it again today. So please don't forget all the things that you already know about asymptotes. What is an asymptote? Oh, yes, yes. It's a line that a graph approaches but doesn't touch. And you guys, we've kind of been talking about asymptotes without actually saying the word asymptote, because you guys, remember we're talking about graphs that like shoot up like this infinitely far, so we would say that their limit approaches positive infinity, or if the graph is headed down, it's headed toward negative infinity. And you know when it does that, the graph is the graphs are usually doing something like this. I'm going to change the color in a minute, but the graph is going, it's like headed down right here, so it's always approaching some line. Well, what is that line called? It's called an asymptote, a vertical asymptote. All right, so today we're going to talk about those just in a little bit more detail. Let me change my pen color first. Uh-oh. What am I doing wrong, you guys?
It's okay. Change the wrong color.
That's not what I meant to do.
There you go.
There we go. Okay, good. All right. I don't know why it seems to work so easily sometimes and not others, but all right, here we go. So first of all, an asymptote. Now I am going to abbreviate asymptotes with VA. Vertical asymptotes with VA. Are you okay with that? It makes it a lot easier to write. Okay. And I think I did that for you guys in Algebra 2 a couple of years ago too. But asymptotes occur when you have an x value where f of x is approaching it toward either positive or negative infinity. You guys already know that. We already talked about it today. All right. We have a vertical asymptote if, and this is where you really need to start listening to what I'm saying. You have a VA, a vertical asymptote, if you have, ignore the limit part of this for just right now. If you have some rational function, in other words, some function divided by another function, and if you plug in some value of x, and the value of x that we're talking about, as we talk about a lot, is the value of c. If you plug it into the bottom and you get 0, and then you plug it into the top and you do not get 0, you're going to have an asymptote there. So we will talk about that with an example here in 2 seconds. So the bottom has to be 0, the top is not going to be 0. Can you remember that?
Yes.
Bottom is 0, top is not 0. What if you get 0 over 0? What happens then?
It's not an
It's not going to be an asymptote. It's got to be 0 over something else on the top. All right. So, an example, x squared plus 1 over x squared minus 1. X squared plus 1 over x squared minus 1. You guys have done this. You probably dream about it at night. Look at the bottom. What value of x will make the bottom of this thing 0? 1 or negative 1. This thing will factor to x plus 1 and x minus 1. Like I said, I've done that before. So that means there might be an asymptote at one of those values, or maybe both of those values. So what you need to do, so I put a little note here, x squared minus 1 equals 0. It equals 0 if x equals 1 or if x equals negative 1. You guys with me here? So what you need to do is take those two potential values and put them into the numerator. And when you put them into the numerator, I literally mean you just replace x with your 1, square and add 1. So you get 1 squared plus 1. 1 squared plus 1 is 2. Is it 0?
No.
No. So what does that mean?
It's an asymptote.
There's going to be an asymptote there. So we have something, we're going to have a 2 on the top, we have a 0 on the bottom, that means an asymptote. Now we got to check the other one. What if we put a negative 1 in for the x squared on top? We're going to have negative 1 squared, which is 1, plus 1 is 2. Now, is it always going to happen like that? No. Sometimes it will work out like that, sometimes it won't. So, it did work out. We have a 2, we have something other than 1 on top, therefore we have an asymptote there. So, x equals 1 and x equals negative 1. Those are both VAs, vertical asymptotes. Okay? Yes.
Is there ever going to be a situation where the bottom isn't 0?
If the bottom is not 0, you have a limit. Okay?
So they just find those.
Yeah, so you would just find it. All right, sample number 2, you should have this written down. Factor the bottom. When you factor the bottom, you have x squared minus 4. That gives you x. That gives you x plus 2, and it gives you x minus 2. So we have potential values at negative 2 and 2. Okay? So we have to check both of them. So I plug a 2 in to the top. And when I plug a 2 into the top, I did the math right here. 2 squared plus 2 times 2 minus 8. I'm not going to go through all the math. You guys can figure that out for yourself. But you get 0.
Another one?
No.
Okay, I'll say.
You get 0. If you get 0, what does that mean?
It's an asymptote.
It is not an asymptote. Okay? I do the other one. I try a negative 2. Square plus 2 times negative 2 minus 8. You get negative 8. What does that mean? It is an asymptote. So
Please
we have.
excuse interruption, but please disregard any fire alarms you are currently hearing throughout this hour. Thank you.
So you do have an asymptote when you have a negative 2. Okay, all right, so put a note here. So x is 2 is not an asymptote, or is not, is not a vertical asymptote. When x is negative 2, it is a vertical asymptote. So this is where we need to start digesting some things. Who cares? We know we have an asymptote there. Well, now we need to start talking about limits. And we're gonna talk today about if you have an asymptote, okay, you know you're gonna have an asymptote. Say you know you have an asymptote right here at 2. You have an asymptote at 2, and you know that if it's an asymptote, as the graph gets closer to it, the graph is either gonna shoot up like this, or it's gonna head down like that. We're gonna work today on which of these two situations happens. Is it gonna shoot up, or is the graph gonna shoot down? Are you with me? If it shoots up, it's heading toward positive infinity. If it's headed down, it's headed toward negative infinity. All right, you need to have your thinking caps on now, because now sometimes the math gets a little bit sticky. So, I wrote down example 1. Again, this is the same thing you already talked about on the previous page, second page I think it was. Maybe it was the first page, I can't remember. So example 1 again. Is the graph, the question now is the graph approaching positive or negative infinity when we get close to those asymptotes? In example 1, we had 2 asymptotes, correct?
Yeah.
We had one at 1, and we had another one at negative 1. So we need to check what's going on as we are headed toward those. We have an asymptote right here at 1. We have another one right here at negative 1. So as I am coming close to negative 1 from the left side, is it shooting up toward positive infinity, or is it headed down toward negative infinity? And what happens as we approach this asymptote from the right? Is it headed up? Is the graph headed down? Because we could have situations where this is going on. We have a curve in the middle. And then maybe the graph is doing this over here. And maybe the graph is up here. We don't know what's going on. And I'm kind of making this up as I go right here, but you can have graphs that look like this. So we're going to check out what's happening as we approach from the left and the right and so on. Okay? All right. So we have asymptotes at 1 and negative 1. So I have this, and some of you guys were asking, what do you do? What's going on here? Positive divided by negative, all that. That's what we're going to talk about right now. So we're going to look at the asymptote at 1. The one on this one over here. What's going on as we approach this value from the left? All right, so now what I would like you guys to do is somewhere in your notebooks, in your notes, somewhere, what I want you to do, and as silly as this sounds, I want you to draw a number line. Draw yourself a number line. I'm going to draw it up here. When I say a number line, what I want you to do is draw it. Don't be stingy. Draw it big. I'm going to put 0 right in the middle of it. And I'm going to take one step to the right, and put a 1, and I'm going to take one step to the left, I'm going to put a -1, and I'm going to put a 2, and I'm going to put a -2. And what I need you guys to do is think about what it means when you are approaching 1 from the left. So I locate 1 in my number line. As you are coming in from the left, that means numbers that are smaller than it. Would you agree?
Yeah.
Okay, so give me a number that is smaller than 1, but really close to 1.
0.9.
0.9. How about 0.999? Yeah?
Yes.
0.999. Okay, so what we're going to do is we're going to see what happens when we approach 1 from the left. What we'll do is try looking at what happens at 0.999. So what I'm going to do is put in 0.999 in for x, both of my x's, and I want you guys to do that right now. Calculators out, punching buttons right now, please. When I take 0.999 and I square it, what do you get? Wayne, what do you get? Say it loud.
-0.00199999.
Okay, you already subtracted, right? You already subtracted 1? Okay, when you take 0.999 and square it, 0.999 squared is what did you say?
0.9980001.
0.99801. All right, and then the next thing that Wing did was she subtracted 1. So subtract 1 from your values. I don't care what the number is, but what kind of a number do you get? You know it's negative. That's why I have a negative here. All right, now we're going to do the same thing on the top. Take that same value, 0.999, square it, and then add 1. What happens? You get a positive. We already know, because we have an asymptote at 1, we already know it's going to either head toward positive infinity or it's going to head toward negative infinity. What we just did here was we figured out that because we're going to always have a positive number when we head in from the left, divided by a negative number, what kind of infinity are we going to have? Negative, because the positive divided by a negative is a negative. Yeah? All right, so now what we need to do is check what happens as we approach it from the right. So if I'm approaching 1 from the right, what kind of numbers am I talking about? Well, give me something that's really close to 1, but just a little bit bigger than it. 1.001. Could we all agree on that? 1.001. Plug it in. Put it in for this x. Put in 1.001 and square it. Then take away 1. What are you going to get? You're going to get a positive number. I hope. Right? What happens here? You put in 1.001, square it. You guys, and then add 1. Obviously, what kind of number are you going to get?
Positive.
You're going to get a positive. So you have a positive divided by a positive. We already know it's headed toward infinity. So what is a positive divided by a positive? Positive. Remember, yesterday I talked to you about how sometimes I'll put the positive sign there, sometimes I won't. If it's not there, it means positive. Okay, obviously. All right. How do you feel about that? Okay?
Yeah.
All right. Let's, now I just erased my number line, so you're going to have to use your number line that you hopefully have drawn in your notes. But now what I want to do is check. We already checked both positive 1 asymptotes. Now we need to check the negative 1 asymptotes, but we need to check both sides. What's happening as we come in from the left? What happens as we come in from the right? So, right now what I need you to do is pick a number close to negative 1. We're coming in from the left. I'm going to draw my number line. I feel weird about it. So, here's my number line. Here's 0. Here's negative 1. I am approaching negative 1 from the left. So, I am coming in from this side, headed toward negative 1. So, I am talking about a value just before negative 1. Give me a negative value. Actually, I shouldn't say that. It's not just before. It's actually just after it. But when we're headed in from the left, it's just before. So negative 1.001. Plug it in. You're going to plug plug in -0.001, you're gonna square it. You guys know whenever you square a number, you always get a positive. And we are squaring a number that is a little bit bigger than 1. And then we're taking away 1. What are we gonna get?
Positive.
Did I? Oh, I'm
You're doing the wrong
here.
one.
I'm like, oh my gosh, it's wrong. I'm looking at the wrong example. Okay, so we have -1 from the left. We square it. You guys agree it's going to be positive?
Yeah.
You guys get a positive number? Do the top. You have some negative number. You're squaring it. You get a positive. You add 1 to it. You get a positive. So again, we have a positive divided by a positive, which is a positive. So it's approaching positive infinity. All right. One more, -1 from the right side. If we're approaching -1 from the right side, that means we're coming in from here, headed toward here. Pick a value right before -1. -0.999. Square it. Subtract 1. What do you get? I don't care what the value is, it's negative. Would you agree? Hopefully. Top, same thing. Plug in, you're going to get a positive here, plus a positive is going to get you a positive, so it's approaching negative infinity. Okay? Example 2 again, and you guys didn't write this down again, so I kind of want you to go. We're going to write it to go. Quickly write down example 2 again. F of x is x squared plus 2x minus 8 over x squared minus 4. And just we'll put a little note here to remind yourself that there was only one asymptote, and that one asymptote was when x was equal to -2. So if there's only one asymptote, we only need to do 2 limits this time. We only need to figure out what's going on as we head in from the left and when we head in from the right. Okay? We know because it's an asymptote, it's either going to be headed toward positive or negative infinity. That's what asymptotes do to graphs. So we are concerned about the actual value of the numerator or the denominator. We are only concerned about if it's positive or if it's negative. I only have to check one value. That one value I have to check is -2. So what we're going to do is check what's going on as you, what happens as you approach -2 from the left. So here's -2. As you're coming in from the left, that means the negative side. So is my graph going to shoot up or is it going to shoot down? I'm going to draw my number line up here. I'm only concerned really about what's going on at -2. So what I'm going to do is pick a value that is what in comparison to -2? A little bit smaller in value, which means it's a little bit more negative. Give me a value that is a little bit more negative. -2.001. All right, now be careful, you guys. It's so important that you are putting parentheses where you need to put parentheses and so on. Put in a -2.001 here. Make sure it's in parentheses. Square it. Subtract 4. And I probably put more words here than you need to put. In fact, I think you should probably just write things as you go. I think this might actually end up being a little more confusing than it needs to be. When you do this, when you square this number, you're going to end up with a positive number, and that positive number is going to be a little bit more than 4. And then you're going to subtract 4 from it. What do you get? What does your calculator say you should get? You get a positive number. That's all you care about. You get a positive number. Now you check the top. Again, you guys have to make sure that you're putting parentheses around these values. You forget the parentheses. You square a negative number. The calculator is not going to make it positive. It's going to leave it negative. And then make sure you put in that same value in for this other x right here next to the 2. Put in a -2.001. Subtract 8 from it. Do you get a negative number? Yes. So when you put a negative in, divided by a positive, you are approaching negative infinity. One more to try, and then we're done. We have to figure out what happens as you approach negative 2 from the right side. So pick a value that is to the right side of negative 2. So give me a value that is to the right side of negative 2. Negative 1.999. Plug it in. You already know what you should get because I already have the answers right in front of your face. But I think it's good practice to try. You plug in that value, you put your parentheses where they are supposed to be. You are going to end up with a negative divided by a negative, which means, of course, that your graph is going to be approaching We'll blame it on China.
Okay.
China. A negative divided by a negative is a positive. All right, and I think I have that in here. I hope.
All the time. You're too long, it's alright.
Positive. How do you feel about this? Good?